So we will start with the hub. It is the most basic of all network devices. It's a layer 1 device. It connects multiple Ethernet devices together to function as a single network segment. They don't read data, they just simply pass it straight through. However, they're very rarely used today because of the inherent security vulnerabilities associated with hubs. That leads us to switches. The switch operates at the data link layer, or layer 2. A network switch connects network segments. It determines which device is connected to each port by its MAC address. They provide much better security than the very old and insecure switches. The network administrator should and must be able to monitor all network traffic. This helps to identify and troubleshoot network problems. There are two basic ways to do this, either by port mirroring or by placing a network tap, separate devices installed between two network devices. It's important to know and understand some of the more common attacks associated with these network devices, such as MAC flooding, or MAC address impersonation, or MAC spoofing, ARP poisoning, port mirroring, and network taps. Now, you could be asking, well, I thought you said that it's a good thing to have port mirroring and network taps. Well, it is, but because of the nature of what they do, capable of seeing and reading all network traffic in the segment, it can also be used against the network. So it's important to understand that it is a vector of attack and secure appropriately. Next, we have routers. The router will forward packets across computer networks. They operate at the network layer, or layer 3. They can be set to filter out specific types of network traffic. Routers can also be used as load balancers to help evenly distribute work across the network and allocate requests among multiple devices. Some of the primary advantages of load balancing: it will reduce the probability of overloading any one single server, and it helps optimize bandwidth of network computers. Load balancing is achieved either through software or hardware devices. Some of the security advantages of load balancing is they can stop attacks directed at a server or application. They can detect and prevent any type of denial of service attack, and some can deny attackers information about the network itself by hiding, for instance, HTTP errors or removing server identification errors from HTTP responses.